Hey everyone, I am Mr. Wagenborg, 7th and 8th grade science teacher and science fair coordinator. So what I'm going to do today is go through all the steps of the science fair project and also how to construct your board. And then at the end I'll show you some sample projects and hopefully this will clear up any questions you have or help you along the way. But as always, if you have any questions after that, feel free to come see me in room 301. Okay, so let's get started. Okay, when you're conducting your experiment, you got to follow the parts of the scientific method. Okay, we are not doing any projects that are demonstrations. Okay, like how a volcano erupts or how the solar system, is how the planets go around the sun in the solar system. We're not doing any taste tests or surveys or things like that. We're doing scientific inquiry where we have a question and we're going to test it. That's what a good scientific question is, something that can be testable, something where you're going to find out by doing, not something you're going to look up through Google or ask somebody's opinion or things like that. Okay, so I'm going to walk you through the steps of the scientific method first. Okay, so the very first thing that your teacher probably had you do was pick a topic. Okay, and that topic is in the form of a problem or a question. Sometimes it's also called the purpose. It's the reason why you are doing the project. What are you trying to find out? All right. So for example, for this whole demonstration, I am going to imagine that I am doing a project on paper towels. And my question is, which paper towel, Bounty, Brawny, or Economy brand, will absorb the most water? So that's the question I am going to find out. That's the question where I'm going to set up a test to find out, okay, and find out my answer. I'm not looking it up. I'm not making it up. I'm not guessing, okay? I am actually going to do this test. So I have my problem, I have my topic, and we're going to get started. Okay? So the very first thing after I have my topic is I'm going to form an educated guess. I'm going to make a hypothesis. Okay? Now, the difference between an educated guess and a regular guess. An educated guess is supported by facts. Okay? It is not just thrown out there. For example, I wouldn't just say, I think Bounty will absorb the most water, or I think Brawny will absorb the most water. I would say, I think that Bounty will absorb the most water because, okay, because, there's your keyword, because it is thicker than the others. Okay? Now, your hypothesis can be based on research. Your hypothesis can be based on prior knowledge or past experiences. Okay? Anything like that, as long as it makes sense. Something that is not good would be, say, because I like it, or because, it's pretty. Okay? Those are not good facts, or no good details, I should say, that back up your hypothesis. Okay? Materials. Now, when you do your materials, when you gather your materials, you are gathering everything you need to do this experiment. Okay? And when you list your materials, you're going to be very specific. You're going to include what type, how much, the size, etc. So if I, for example, read your report, okay, or look at your board, I could be able to copy that project to a T. I would know exactly what you used. Okay, this way I would see if my results match yours. That's what good scientists do. They look at each other's work, they check each other's work. So in this case, okay, I would say 1 styrofoam cup instead of just saying a cup. Okay, or 1 200 milliliter glass beaker instead of just saying a measuring cup or something like that. Okay, I tell you how many sheets of Bounty, how many sheets of Brawny. I tell you the size of the aluminum pan and how much tap water I use. Okay, again, you want to be very, very specific when you are listing your materials and when you're gathering what you need. Okay, so if you're following a procedure that's already done for you, or you're making this up yourself, it's very important. You don't just do random measurements. Okay, you got to be specific because those measurements could play a part in the outcome of your project. Okay, procedure. Okay, just like the picture shows, it's steps. Okay, these are the steps you are following. Now again, a lot of you are getting your project from the internet, so the steps are done for you. Some of you are creating your own question, creating your own topic, so you're going to have to make up your steps. Now, regardless of what you do, you have to include every single step that you do. In the past, some people have forgot to say that I took all three, for example, all three measurements added them up, divided by 3 to find the average. People forget to say that. Or people forget to say that I repeated this for 2 more trials. Okay, you've got to include every single one, and it's got to be chronologically ordered. Okay, so you don't just put them randomly. Don't put them in a paragraph. List them step by step. Again, if I wanted to do this project, I would want to know, what do I do first? What do I do second, third, fourth, and everything like that. So just some things to point out. I just noticed, like, I just put in here for step 5, repeat steps 1 to 4 2 more times. Okay, or repeat steps 1 to 7 with Bounty and Brawny and Economy brand. Okay, I'm telling exactly what I did. Now, when you do a project, now some people can't do it based on it, but most of you can. You should aim for doing 3 different types, 3 different brands, 3 different times doing it. Okay, because one time could be an anomaly. One time could just be something unique. But if you do it multiple times, the more times you do it, the more valid your results are. Okay, so that's why you want to aim for multiple trials, multiple brands, multiple types, etc. Okay, your observations and your data. You are writing down exactly what you see or what you measured. Don't just tell me or your teacher or your classmates what happened at the end. You want to know what is happening all during the experiment. Okay, after a minute, after 2 minutes, after 1 day, after 3 days, whatever. Don't just say what happened at the end, because if you include just the measurements at the end, okay, that's not all your data, all right? You're just telling me your final result, and that's not what we want, okay? So using your 5 senses, okay, when you're making your observations, what did you see? What do you smell? What do you hear? What do you touch? Okay, if you're just doing measurements, what was the time? What was the centimeters, etc.? Okay, remember when you're doing measurements, make sure you do the metric scale. Okay, don't put inches or feet or things like that. Make sure it's centimeters, meters, okay, because it's science. That's what we do in science. Okay? So for example, 3 Bounty towels absorbed a total of 178 milliliters. Okay, I said how many towels there were, and I went with that. Now, observations also are a good place to have pictures. Now, my 7th and 8th graders, okay, my 7th and 8th graders are going to have to provide proof of evidence that you did the project, okay? So pictures could be put here, okay? Or pictures could be just brought in on a phone or video or something like that. I'll get more into that later, but just to keep an eye on that you have to provide proof that you actually did the experiment. But again, this would be a good place to actually put your pictures, okay? We'll get to that in a minute. All right, the results. In the past, everybody gets all confused about the results, and the results are pretty much the easiest thing you got to do because you don't have to do anything new. What you're going to do is take all your data from your observations, from that last section, and you're going to make a chart or a graph or a table out of it. So for example, what I did here was I took my 3 measurements of Bounty, Brawny, and Economy brand, and I made a bar graph out of it. Okay? Why do we do this? Because it's very easy to read and understand. You don't have to read through pages of data or all these numbers. It's very easy when it's pictured like this in detail. Okay? Make sure you label everything. You want to label, I'm talking math now, you want to label your y-axis, your x-axis, and have a title. Okay? You want to make sure that everybody knows exactly what the data is showing. Okay? Then we get to our conclusion. This is your wrap-up. This is your reflection. This is where you look at whether your hypothesis was right, what happened in the experiment, what you do differently next time. Okay? Now, we have 5 questions that have to be answered. All 5. You're not just answering 1, you're not answering 2, but all 5 questions have to be answered in detail. So question number 1, was your hypothesis correct? You go back to your guess, your educated guess, and you see whether it was right or not. So you're going to compare your hypothesis to the results. All right? Again, don't think that you did something wrong because your guess was wrong. That was just a guess. It was an educated guess. All right? Don't think you did your whole project. Or don't say, oh, I got to change my results to that. No. Your grade's not based on your hypothesis. All right? Number 2, explain why you think you got the results that you did. Why do you think happened? All right? What was it? What do you think it was? Please, please, please do not write down because I followed the steps properly. Okay, or I was careful when I measured. No, I'm not worried about how you got it. I want to know, why do you think it happened? Why did the outcome occur? Number 3, possible errors. The most careful scientists in the world, okay, Has mistakes happened during the experiment? Okay? Sometimes they're blatant, sometimes you got to think about it. Okay? So you're going to list 3 possible errors that could have happened. All right? If you were timing something, maybe you didn't hit the timer fast enough. Okay? Or maybe your ruler wasn't straight. Or maybe you weren't careful when you measured out each cup of water. Or maybe you looked at your plants at a different time. Whatever it was. 3. Okay? 3 possible errors. Make sure, again, before I go on, everything's got to be in complete sentences. You don't want phrases, you don't want words. It should be a complete sentence. Okay? Number 1, here's my answer. Number 2, here's my answer. Number 3, with the 3 errors, here's my answer. Number 4, 3 possibilities that you could do differently next time. If you did the same exact project over again, what are 3 things that you would change? What would you want to see differently? What are you curious about? Okay, this happened this time. Well, what if I change this? What if I change that? Okay? Now, finally, this is the one that gives most people trouble, and in the past, this is the one that's caused people to lose the most points. Explain what you learned by applying your results to the real world. You are not writing down exactly what happened. I know what happened. I saw your results. I saw questions 1 and 2 and your conclusion. You're telling me, okay, this happened. Now, how am I going to apply it? How is that going to affect my life? What can I use this data? What can I use this stuff for in my own world? Okay, so let's go back to my problem. My problem, remember, was which paper towel is going to absorb the most water. So I'm answering my 5 conclusion questions. My hypothesis was correct because Bounty was the most absorbent of the 3 brands, and that is what I predicted. So again, I go back to my hypothesis. I compare it to what happened. Number 2, I think this is because Bounty was the thickest, which could mean that the materials used to produce it were of higher quality. Again, I'm telling you why I think happened. Why did Bounty absorb the most water? That's what I think. Number 3, some errors that could have occurred if, 1, I did not use the same amount of water each time. 2, I did not wring each towel out the same way. Or 3, my paper towels were not exactly the same size. Those are 3 possible things that I could have done wrong, that I wasn't careful about in the experiment that could have affected my results. Number 4, next time, I might try using the same price towels, that's 1, using a different liquid like juice, or changing the temperature of the water to see if it makes a difference. Okay? Those are 3 different things I would try differently next time. Now finally, the bottom. What did I learn? I learned that quality and performance of a product could be related to the price you pay. Okay? This is because the price usually has something to do with the quality of materials that are used. So I could apply what I learned with paper towels to everything. Yeah, you pay a little bit more at the grocery store for a certain food or a certain product, but you get what you pay for. Okay? This is what I learned by doing it. And that's what I'm looking for that 5th part of the conclusion. How is it going to affect your life? Don't simply just rewrite, oh, I learned that Bounty absorbs a lot of water. No, that doesn't tell me anything. I know that already. Okay? How is this going to affect you personally? What did you learn? That's the whole reason why we're doing this. What did you learn, and how does it affect your life? All right, your logbook. Your logbook, one of the easiest parts that, again, people mess up. Your logbook is simply your data that you are writing down as the experiment goes on. It's kind of like your rough draft, your rough copy. It's kind of like scientists out in the field. They have a little notebook in the back of their pants or something like that, and they pull it out, or their bag, they pull it out and they jot stuff down. Oh, this is what I see happening. Or these were my measurements this day. Okay, you're writing this down. It does not have to be typed. Okay, it's got a handwritten, you put the date, it can be typed if you want, but handwritten, written all out, okay, stapled together. It could just be a bunch of pieces of loose leaf stapled together, or it could be a copybook, or it could be something more formal. Okay? As long as you have all of your data, whatever you wrote in the data section, the observation sections, in the other part of the experiment, the scientific process, this is where this goes first. Okay? This is where this goes first. Okay? Now, we did the project, which is the most important thing. You did the project, now it's time to display it. Now it's time to build your board. Okay? All of the information has to be typed and put on a standard size tri-fold board, not a small tiny one. Okay, standard size boards. Now, normally we give out boards or sell boards. We sell the standardized ones. Okay, I have sample boards which I'm going to show you if you have a question about how big the board is. okay? But the standard size board, it shouldn't be tiny. If it's tiny, you're not following directions and your grade will suffer immensely, all right? Your name and room number should be on the back of the board. The back of the board. That's where you write it, right on the back of the board, okay? Your board should be in order, which I'm going to show you the parts in a minute. Neat, spelling and grammar. Nothing is worse than having a board where a whole bunch of spelling mistakes or a whole bunch of grammatical errors, or it's ripped, or it's sloppily painted or colored or whatever. Creative. Make sure it's colorful and decorative with pictures. You don't want to just print a page out, for example, with your question, conclusion, whatever, and just put it white on white. A white paper on white board. It doesn't look good at all. Okay, it does not look good at all. All right, so another thing is your project title. Your project title should be at the top of your board, not on your board. It should be sticking up. It should look kind of like a marquee at a movie theater that displays what movie's playing. Okay, nice and big. Okay, you want people to go to this movie. You want people to look at your board. All right, so be creative with your title. Maybe you rhyme. Maybe you use a movie title or a song title that has to do with your project. Okay, maybe you put your own name in there, whatever. Make it creative. Okay, don't make it boring. And it is not the question. The question is something different. You're not putting the question up for your title. Okay, so for example, the tremendous tournament of towels. Okay, see how I use the T's. All right, instead of just saying paper towel or which paper towels. No, that's a question. So the tremendous tournament of towels, a little tongue twister there, okay? We thank Olympic champion Lindsey Vaughn for helping us out with the picture here, okay? But these are some of the things that you can do, some of the things that you can explore and be creative with, okay? So your board should be set up relatively in what I'm going to show you, relatively in the same order. Some parts can be moved around, but you want it to flow in the order that you did. You don't want people looking around. Oh, where's your results? Where was your hypothesis? All right, you want it to flow. Now, there's another thing. You don't have that much room on the board, especially if you have long procedures or long conclusions. What I suggest is you staple the pages together for multiple pages. So if your procedure is very, very long, well, staple your procedure together and then put it right on the board. People can flip through it rather than having the procedure take up most of the space or the conclusion take up most of the space. Okay, it saves time. All right? So again, your title should be on top of the board, but you should have your problem, your hypothesis, and your materials. Okay? Your procedure, right in the middle, with your results of your graph, your observations, and your conclusions. Now, you can, 1, 2, 3, and 4, and this one should be there. If you want to flip-flop results and observations, that's fine too. Some people have a lot of observations, so they need a lot of space. Some people don't. Some people have big graphs, big charts, big tables. Some people have multiple tables and charts. So that's where you can kind of wiggle room, okay? But conclusions definitely need to be last, okay? Problem, hypothesis, materials, procedure. And again, title on top of the board, okay? So what I'm going to do now is show some sample projects from years past, okay? All of these were high-quality projects. All of these were done a little differently, okay, and that's why I picked them, but they're all pretty much current. So we're going to start with this one over here. This was done by Merrilee when she was in 7th grade, okay. Let's get personal with fruit. Notice her title. See how it's stuck up, okay. It's something different. It's creative, all right. Now, look how she typed everything. She cut it out, and then she put border behind all of her sections. Notice how each section is titled, okay? Problem, hypothesis, materials, procedures, results, observations, conclusions. Notice also how each title is the same font, size, and style, okay? You don't have different font sizes, you have different titles. Now, she drew, because she was a good artist, she drew DNA, but she also included the pictures, like I was saying before, of her actual project. Okay? She has a table of all her trials, okay, like that. Her logbook, okay, I have right here. She had it on, I think it was attached to the back. Okay, now with the logbook, some people put folders and glue them on the back, or some people glue it right on the back. I would not clip it with a paper clip because it will fall off. Okay, but her logbook, it's dated, okay? March 16, 2019, first trial, and it's got everything that happened, okay? Goes back here, March 18th, third trial, everything that happened. Now, she also included more pictures in her logbook. This is above and beyond what you have to do, but again, it's something you could do. Again, that's what the logbook, again, she typed it, okay? You don't have to type the logbook. All the stuff on the board has to be typed, but the logbook can be handwritten, okay? And again, you want it somewhere on the back. Okay, we're gonna go over here to Joyce's. Okay, one fish, two fish. So again, she referred to a Dr. Seuss book, okay, for hers. Again, she's got her titles. These are all of her observations, okay, because she did it over a 14-day period. So again, she didn't just tell me what happened on the 14th day. She told me all throughout what happened, okay? And again, she has actual pictures there as well, and she has her bar graph. Again, title on top. Okay, and finally we have Ryan's over here. Okay, confusion about diffusion. Again, he rhymed. Title up there. Notice again the background. Notice the font size is consistent all the way through. The style. He has his actual pictures as well of what happens. Okay, he's got a lot of different charts, a lot of different tables. Okay, so he went above and beyond as well. Okay, again, if I flip to the back, name, get his room number, okay, and that's where he kept his logbook. He kept his logbook in a envelope like that. So you can put it in an envelope, you can put it in a folder, okay, whatever. But like I said, if you attach it with a clip or a paper clip, something like that, it's going to fall off. And especially when they're out in the hallway, and especially if your board is great, okay, we're going to have a problem because your logbook is going to be missing. All right. Now, what happens after this? You turn your project in on the due date, whatever the due date is for that year. And then we have a Meet the Scientist Day. During the Meet the Scientist Day, you'll have your boards all displayed in the hallway. You'll be sitting next to your board so the different classes can walk around, different teachers can walk around and ask you questions about your board and your project. Then you'll also get the opportunity to do the same thing with other people's boards. You'll have nominations for each of your grades. Okay, so your science teacher will nominate a certain amount of people for each grade, and they will be judged. We will have first place, second place, third place, and honorable mention. And we'll have an awards ceremony, an awards assembly, okay, where you'll be honored with that. Now, questions, if anybody has any questions, obviously your science teacher is, your first stop. But I'm in room 301 upstairs on the 3rd floor. So if anybody has any questions whatsoever about this, okay, please ask me. Now, I know some science teachers have already given you a slideshow, but I will also send them this slideshow as well that I did in this video. And like I said, if you want to talk to me anytime before, after school, if you get permission during homeroom, whatever. Okay? But I wish you the best of luck, all right? Make this a fun experience. Don't make this, something like, oh my gosh, a science fair, okay? Because people do learn. And when high school kids, college kids, and even the kids that are in their, adults that are in their 20s and 30s, always remember their science fair for whatever reason, okay? Whether it was something positive, something crazy, or something that didn't work, okay? So good luck with you, okay? Keep on sciencing. Have a great day. See you.